Hi, Mike Roby here, and today I wanted to talk about why are we here? Why am I here, more specifically? Not the metaphysical, existential, why are we all here? That's for the philosophy majors to decide. No, why am I in college? What do I expect to get out of it? And the short answer is a career in electrical engineering, which begs the question, what does an electrical engineer do? Now, if you ask the U.S. Bureau of Labor Statistics, they'll say that electrical engineers design, develop, test, and supervise the manufacture of electrical equipment, which is great and all for the label on the box, but we got to unpack that statement to see a little bit more and get at the heart of what electrical engineers do. So, electrical engineers are problem solvers who use ingenuity and versatility to be able to solve problems, and I'm actually going to talk about those today. So, to get into problem solving, I want to talk about the history of the transistor. And this is from an article in the San Jose State University website about the history of the transistor. It's fantastic. But the transistor was first developed in 1947 as a response to the current computers of the day, the best of which was ENIAC, which was used by the U.S. Army to develop or to determine U.S. artillery trajectories. And the three problems with ENIAC were that it was big, took a lot of power, and it broke a lot. The computing power that it used vacuum tubes, and vacuum tubes broke a lot. And so the inventor of ENIAC got together with a couple of electrical engineers and developed a solution using molecular silicon to make the transistor. And to put that another way, an electrical engineer came in, saw a problem, assessed possible solutions, designed, developed, and tested solutions, and then presented the solution he came up with to the public. And the solution he came up with, the transistor, is what we use now in current computing. It's responsible for everything from personal computers to laptops to smartphones to the internet to the space station. All of it uses transistors. And if we hadn't taken an engineering design process to it, we would not be where we are right now. And I should point out, I feel the need to make a point about versatility, because electrical engineers don't just focus on transistors or electronic components. They focus on everything from electrical components to integrated circuits in vehicles to buildings to NASA, the Mars rover, Voyager probe, the Kepler Space Telescope, the ISS all have integrated circuits that electrical engineers designed on them. And because the electrical engineers are such problem solvers, because versatility is so ingrained, it allows them to use ingenuity every day to be able to come up with solutions to problems. Just looking through the Encyclopedia Britannica, several of the more famous electrical engineers, Nikola Tesla, for example, used an ingenious solution to improve DC, or direct current, in his alternating current model to develop things like wireless transmission, X-ray imaging, radio control. All of these things because his ingenuity in solving the problem he was tasked with solving. Ray Dolby, you probably know his name from every single feature film that's been developed. It's Dolby Digital. He was trying to remove the audio hiss in his audio recordings, but because he used his ingenuity in doing so, he developed active noise canceling, the noise canceling headphones that we use now. And just to bring it all in, engineers use that problem-solving methodology, their versatility and their ingenuity, to bring together a group of problem solvers, movers and shakers, inventors, eccentrics, and I'm trying to be one of them.